Okay, so as mentioned in the email this video is attached to, in a dart gun, a spring with K equal 400 newtons per meters is compressed 8 centimeters when the dart with a mass of 20 grams is loaded. What is the muzzle speed of the dart when the spring is released? Ignore friction. Well, the elastic energy initially stored in the spring is converted into kinetic energy of the dart as the spring expands. And there's no change in the gravitational potential energy since the motion of the dart is going to be horizontal. And the vertical normal forces do not work because they are perpendicular to the displacement of the dart. So the spring pushes the dart to the right until it reaches its relaxed length. And we can go ahead and assume the spring can't pull the dart to the left because if it did that, they would just stick together. So the dart loses contact with the spring when the spring is at its relaxed length. And so for this, I chose the origin at the relaxed position of the spring to make the final x equal to 0, and then using the x-axis, I made the initial x is equal to negative 8 centimeters, and the dart starts from rest, so the initial velocity is going to be equal to 0. So what we need to find is the final velocity. And now here, as you can see in the diagram, I drew the compressed spring to the left and the relaxed spring to the right, and illustrates exactly what I was just saying about the initial x is negative 8 centimeters in the compressed spring, and then it goes to the final x is at 0 centimeters when it's relaxed. And then since we're ignoring friction, no work is done by the non-conservative forces, so therefore the mechanical energy is constant using the formula K sub I plus U sub I is equal to K sub F plus U sub F. And we can ignore the gravitational potential energy because it doesn't change. And then using the equation for elastic potential energy in the spring, which is 1/2 mv sub I squared plus 1/2 kx sub I squared is equal to 1/2 mv sub f squared plus 1/2 kx sub f squared. And then after plugging in my values of the final x equal to 0 and the initial velocity equal to 0, I get the formula of 0 plus 1/2 kx sub I squared is equal to 1/2 mv sub f squared plus 0. And then going ahead and solving for the final velocity, I use the formula Vf is equal to the square root of k divided by m times the initial x. And all I did was plug in my values for that, and I got that the speed of the dart when the spring is released is 11 meters per second.